what I want to talk about is Solr's autoscaling framework that we've been building out over the last couple of years. And I'm going to speak about some concepts, then tell you guys where are we at and what I feel is the direction that we are headed towards. So quick introduction about myself. I'm Varun. I work for Lucidworks. Been working on Solr for quite a while, maybe 5, 6 years. I'm a committer to the project, and my day job essentially involves helping our customers implement solar and fusion solutions, and mostly geared towards the scale or the indexing and the query, like the scale aspects towards those. So that's where my focus has been over the last few years. Now, like I said, we're going to understand why do we need something like autoscaling? What does it even mean when I say autoscaling? What are the some terminologies associated with autoscaling? And then what are these new features called autoscaling suggestions that come with it? So let's start with why do we need autoscaling, right? Like, what is autoscaling? Why do we need it? When we set out to go, like, why what we noticed is a lot of users were building these tools, extensive tools around managing their cluster and having to have a lot of expertise in-house, knowing what Solr is and how it performs and the guts of like what is replication, what happens when a node goes into recovery, what is a leader, if leaders happen to be on a single node, how do these affect CPU characteristics? So they were really needed to understand the guts of Solr, even from a team that is just managing Solr as an ops team, right? So the entry to barrier was tougher. Maintaining such a big team is not easy, not trivial. Of course, if you were then asked to say, you know what, figure out in my 20 node cluster, why is CPU high on only one node, right? You wasted like a week trying to debug, right? Like, because there's no tooling out there, you want to see whether indexing is the cause, whether it's a hot collection, if you're a multi-tenant application, if it's one tenant which happens to sit on that machine that is indexing and querying mode that is causing it. So you basically go on this wild chase and you have no idea where to start, right? So we wanted to provide tools that make it easy for you to understand these things, and firstly not allow certain constraints and like give you some options to spread the load across your cluster. So that was the motivation. If you were to put it in a sentence, the way we put out a goal was, if Solr was to scale to 1 trillion documents without adding much human intervention, right? So you don't need to 10x your Solr ops team to add 10x more use cases within Solr, right? Now, Solr will help you do the right thing is like what we'll try to achieve in this framework. And let's say you want to add a node. Let's say you want to remove a node from your cluster because you feel like, hey, my Thanksgiving load is over. Now I have all these spare machines. How to get rid of them in a safe way? And given the nodes that I have, how do I keep them balanced, right? These are things that sound simple and obvious that you want to do as an ops person, but how do you go about achieving this and doing it on a live production system might not be very intuitive and easy for you to achieve. So some terminologies in a nutshell, right? Anything that you define as a rule in Solr is called a policy within the framework. So I'm going to define a rule to do something like don't allow a certain operation on a certain node. That is a rule. Now, anytime you want to sort on nodes in a given cluster to figure out which one's the best eligible candidate, that is broadly defined in the syntax as preferences. So you define these policies, you define preferences, and at the end what you get is two things. Which operations will help us take us to the desired state to make the cluster stable or to balance the load, and when to perform these operations, right? So let's start with the first part of it, which is policies. So I'm going to talk about like 5 examples of 5 policies that if you feel like these should be certain constraints, you want to apply to every operation within the cluster. Now, when I say every operations, I'm not talking about updates or searches in this talk. I'm going to be referring to it as, be it a create collection call, or you want to add a replica, you want to move a replica. So any operation to change the topology of the cluster, you want to apply these rules to it. So let's start with the first rule and how do you set that up, right? I'm coming up with a very simple rule which says, hey, you know what? 2 replicas of a same shard should never be on the same Solr JVM, right? Seems simple. Some might think at this point, hey, Solr didn't do this already? Like there were ways you could like violate this in today's world, right? So all I'm saying is, never should we have 2 replicas of a same shard on the same JVM, thereby achieving that my replicas are more spread out across the cluster. So it's a simple syntax here where we say replica less than 2 for each shard on any node, right? So this is a rule that we can create, and then Solr will ensure that never 2 replicas will sit on the same JVM. Let's take another rule. So people in the AWS world call it availability zones. Roughly categorizing it, you can call it a rack awareness of sorts. You want to say that I have 2 availability zones, spread both my copies of the index, so spread both my replicas across them. So you might have 20 machines on availability zone 1, you might have 20 machines on availability zone 2. What is to tell Solr that 2 replicas don't end up on the same availability zone? So the way to do this is, when you start up every instance within Solr, you define this system property. So you start up every node in Solr and just say -d sysprop.az, or you can give it any variable name you want to, and you say rack1 or availability zone east, and you start the other 20 and you specify availability zone west, right? So Solr knows these tags when you started up these instances, and this policy rule framework is just allowing you to leverage that fact. So what I'm going to say is replica equal, all replicas spread it out equally, so it's replica colon equal for each shard where sysprop.az, that's the parameter I said east or west when I started my instances, each. So I'm going to say spread them out across both availability zones as like for every operation. Now the third policy is at a higher level. So it's at a cluster level, where let's take a step back and like we've been talking about replicas. I'll take a quick second to explain what a core is. So in this case, what you're saying is a core is a replica. Oops. Am I stepping on it? Okay. A replica is a core in a sense. Now, a core can belong to any shard, any shard. So that's why when we refer to it as cores, we are trying to abstract away the fact that it should belong to a shard or a collection. So this rule is for a cluster. So we are saying all cores, like spread out cores equally amongst my nodes. So if I have 2 machines, and there should never be a scenario where I have 5 replicas of different collections only going to machine 1 and Solr never utilizing machine 2. So I'm giving it a rule by saying always try to ensure that the next replica you add, try to spread them out as much as possible across your cluster. So this is the third rule I talked about. The fourth rule I'm talking about is in today's world, a lot of users are spinning up multiple JVMs on the same physical machine. But if the machine goes down, all your replicas of that shard go down, right? So it's not really providing you redundancy in the terms you thought it would. So here, Solr already knows your host name when you start up Solr, right? It knows the IP address. So all I'm saying is always have replicas less than 2, which is 1 basically, right? On any host. So never should I be in a scenario where I'm spinning up 5 JVMs on the same physical host, that Solr should assign multiple replicas on different JVMs but in the same physical host. So you're kind of getting redundancy on a higher level in this example. Did I skip one? Oh, I guess I had 4. So these were 4 examples that I spoke about where I'm defining hard and fast rules in the system. Now we get to this part where we start understanding what is a preference. So those were called policies. Essentially policies, I like to think of it as a grammar to compare 2 apples, to say which apple looks prettier than the other or something, right? So you take 2 Solr JVMs and you try to understand which Solr JVM is more fit for this operation, so or more appropriate for this operation, right? So the way the syntax works is it's a language to define load within your cluster. Like I said, it's on a cluster, so preferences don't really apply at a per collection level like some of the rules were. It's more at a cluster level. So load is at a cluster, not at a per collection level. These are not hard conditions. These are just criteria to help us sort machines. Now, you can either choose to minimize or you can choose to maximize on these metrics. So for some example, some of the metrics here are the number of cores on a machine. So you're saying if I was to pick 2 Solr JVMs, pick the one that has the least number of Solr cores on it. So you pick a metric which is either a cores, or you say pick it on free disk. You can say based on the heap usage of my cluster or of my Solr JVM, or you can say based on the load average of that machine. So you can pick, for example, these 4 metrics and say, hey, if it's cores, it should be the least number of cores or the maximum number of free disk. So you're basically specifying these criteria that are more important to you. So here are some examples, right? You always want to minimize the number of cores on a given JVM. So like you want to maximize free disk. Now, when you say just maximize free disk, it's a little ambiguous because at some point you will have these small interim windows where, say you're doing a Solr recovery or your transaction log size grows a little higher. So the disk usage might fluctuate a little. So we also have a precision that you could set to say, you know what, if it's within a 10 gigabyte range, it's probably the same. Or I'm doing some segment merging, Lucene is doing some segment merging in the background. So I allow you to give it a precision level. So the syntax essentially goes like, you give it the sort order, the metric, and optionally a precision level to it, right? Now, all of these, like I said, ties to collection APIs, right? So every time you create a collection, you add a replica, you split a shard, you create a shard. So if you're using implicit routing, or if you restore a backed up collection, these rules of preferences and policies would be applied and taken into consideration. All right? So how does it actually work, right? Now, essentially, when let's say you want to add a replica, right? So for the purposes of this example, we're going to say I want to add a replica, and I have 10 machines on my cluster. So I'm going to go through all the preferences that were defined and try to figure out which machine is the most eligible candidate for the addition of this extra replica, right? So you could have defined that I care about free disk. You could have defined I want to care about cores. You want to say that, hey, you know what, latency is an issue, so the system load average should never go high. So whatever criteria you define, Solr is going to sort all the machines on your cluster based on these preferences, right? So you have all 10 nodes sorted in order of the best to the worst internally. At that point, all the rules that you had defined, so if you defined a rule that, you know what, it should be on the same physical host, if it should be spread across availability zones, so all the rules that you had defined through policies, Solr will apply those on each of them, and at the end pick a machine that fit both the rules and was the most kind of fit the preferences and satisfy those as well, right? So essentially what you're getting is thinking of rules and policies always being hard conditions on your cluster. So if you're violating it, you're never going to be able to add that replica. And preferences being that which machine should I pick, given that from my 10 node cluster, 5 are now eligible from the set of rules, right? So that's why Solr decided to have this distinction between a preference and a policy, right? So where do we want to go to at this point, right? Now, while going through these examples, how many of these examples people were like, hey, you know what? That makes perfect sense. Why shouldn't it be a default, right? Why should you never always why should you never not maximize on free disk? Or why should you never try to keep all the cores in the cluster balanced, right? Most of these rules kind of made sense to have it by default. So starting 7.6 or the next version of Solr that will come out, we're going to take some of these common use cases and start putting them on defaults. So all you need to then say is, you know what, I want to add a replica and Solr will have these defaults, and if you want to have something hand tailored, you can of course change those and remove those, right? So at this point, we feel like a lot of these plumbing has been done. We want to start leveraging this by default because no one should have to listen through a 40-minute talk, read through 4 reference guide pages to start utilizing these features, right? You want some basic defaults to always happen. So these are the defaults that we'll start adding in future versions starting from now onwards in Solr. Now that we've covered like policies and preferences, the one problem that you can have is you set this policy that, you know what, never assign a replica on a JVM which has less than 500 gigabytes index space, disk space, right? You set that up. At that point, you had a terabyte of disk space, Solr assigned it, and you're running happily, right? But over time, your index grows, or in this case, it grew, and now the policy is violated. So you've reached a scenario where that policy, you have less than say 300 gigabytes disk space, but while assigning it, that wasn't the case, right? So at this point, how do we want to move things around so that we can still maintain this sort of a stability and uniformity in the cluster, right? Those are things that we want to start leveraging through suggestions to tell you, you know what, you need to move a replica from machine 1 to machine 2 because this policy is being violated. Things of that nature. So suggestions are operation recommendations according to the policies and preferences. Suggestions are only made when violations are when you are violating these active policies, and they are calculated at runtime. What that means is every time you hit the suggestions endpoint, Solr will calculate, hey, you know what, based on these policies, these preferences, based on these nodes, I will just quickly do the math and give you what all needs to be done at that given instance. So at different intervals, you can get different outputs. So keep that in mind when you're kind of running suggestions. So let's see the first suggestion you want to get. I want to get a suggestion that if my disk space rule is violated, I want to get a suggestion. So that's something we added in Solr 7.2. So if you hit the suggestion endpoint and if that's something that has gone over, we will start recommending those as suggestions. Now what does suggestion give you? It not only will tell you, hey, you know what, disk space has been violated, and that is it. It will go a step beyond and it will tell you that if you can move a replica from machine 1 to machine 2, only then show this suggestion. So it wouldn't show you that, hey, you know what, there's nothing you can do. So it will only recommend a suggestion if there is an operation in the cluster that can be performed. The second suggestion which we added recently, so the next version of Solr will have it, is replication factor. So this is something where you start up a collection, you say, I want 3 replicas of a given collection, right? So every shard will have 3 replicas. What happens is maybe a host went down. So for the last day, you've been having 2 replicas, you've been running off 2 replicas. So firstly, I want to get a suggestion that, hey, you know what, you can add a 3rd replica on some other machine by clicking this operation, and you will be able to regain this replication factor. So Solr by default will not automatically add replicas for you. Okay, so that's a suggestion that we are adding in the next version. It's already there, so whichever version comes out should have this suggestion. So on that note, the autoscaling framework, what we also added during this process was this feature called auto add replicas. So people that are using or were using Hadoop were kind of familiar with this concept. We always supported this in Hadoop file systems for the longest time. For the last series of Solr in 7, we've kind of extended this parameter for non-Hadoop file systems as well, right? So what it does is that when you created a collection and you said replication factor of 3, if the replication factor becomes 2 at that point, Solr will wait for some time, a configurable amount of time that is, and then move this replica or add another replica to the some other machine on the cluster. So it can potentially add if you wanted to. The way to do that is when you're creating a collection, all you need to specify is auto add replicas equal to true. Now that we want to come to more complex suggestions. So given a cluster, how do I rebalance it? So how do I make sure that I want to move cores around or replicas around so that my load is similar across the machines, right? So these are the more complex suggestions that we are now starting to tackle, where essentially it's not an easy problem to say, you know what, move this from one machine to the other and you'll be done. Because sometimes you do that and then that machine can violate the threshold, right? So these are the things that we are kind of working towards, where adding more robust suggestions and suggestions to at a higher level. Hey, I want to balance my cluster. Hey, I want my leaders to not be all on one machine. Do it gracefully. Where to balance my indexing leaders of my cluster. So those are the suggestions that we'll be adding in the future, and that's where we are headed. So that kind of wraps up the rules part of it and the new suggestions part that we are adding to it. So that's all I had for it. Thank you. Okay, so this is a problem if you have, say, a lot of collections. And so the question is, I referred to indexing leaders, and the question was, what does that mean in context of Solr Cloud? So the answer to that is, let's say you have 100 machines and you have a few hundred collections. The first, and all the machines right now are cold, it's stopped, right? So none of the Solr machines are running, and now you start booting them up. So the first few machines of the cluster will get the shard leaders. So every shard has its leader, which is where the document first gets routed to for the add or the update of the document. So what happens is that the first few machines of your cluster tend to have these hotspots because all the leaders are there and they're doing this slight extra work, which, given these many collections, is causing the CPU on those first few machines to be higher than the rest. So graceful ways in which I can balance those across as well. Yeah, can you go?
So instead of having the suggestions offer a recommendation, can you have it perform that operation automatically?
It actually does. So I forgot to add it in the slides, but essentially there's a new Solr admin tab in the UI called Suggestions, where it lists the suggestion. You can have a look at it, and then there's a button to say click, and Solr will just run that operation for you. So at this point, we don't want to do things automatically, but you can see it and you can click it. So when he said move replica, you don't need to know that it involves an add and a delete or which machine to which machine. You just click that, and if you see, you know what, that looks right, let's click it. That's all you need to do. Yes.
Are there any plans to implement through autoscaling?
So remember how I spoke about the policies and preferences? For the longest time, even till today's Solr 7.5, you need to define them manually. And then you need to be able to say, apply these at a collection create call, things like that. Now at Solr 7.6, there's an issue out there where we're going to start making that defaults. What that means is we're gaining more confidence about the system to do some basic things in the correct way. So suggestions is now something that we're building, and at some point, given enough feedback, given enough users, maybe there should be an option to say all of autoscaling should be a Boolean. Should you allow Solr to move things around, or do you want to manually move things around? Like, so the surface area could be reduced to simple like Booleans like that, but as of now, the suggestions will just be an output which you can optionally click.
And when you say optionally click, I guess there's an API to
Correct.
to execute it.
Yes. So the suggestions will list out the operation that needs to be done on the cluster, and the UI has basically a click button, which will actually fire the internal Solr admin calls to actually execute.
Possible to consume the suggestions API
It is. It's a REST endpoint.
and then initiate the action by yourself.
Right.
Basically, these are pre-existing collection level commands that
Yeah.
are being.
So whatever's being leveraged is a call that already exists in Solr. It's the combination. It can be a combination of couple of calls, things like that. SAB?
Just to clarify, the ability to do this automatically already exists in all 7.x versions. Solr just doesn't use this by default, doesn't run this automatically by default because we weren't so confident that this whole autoscaling framework was solid enough. Now, as we gain enough confidence, we are turning on more and more of these automatic features by default.
Yeah.
So you talked
Right.
say you define a preference saying that, hey, I want to assign shards based on like their size, for example, and now there are like 5 possible shards which are candidates based on your policies that can be assigned. How do you pick? Like, how does Solr pick like one of these? Like, is it
So,
usually like the first one in sorted order, or
so it's going to use the preferences to sort the nodes, and the top like, so it could be, say, if your preference criteria was free disk, so it's going to go and sort it from highest free disk to lowest free disk, and on the first node that it picks, it'll try applying all the rules, and if it's met, it'll use that.
okay, but can you get like a situation where like, so if you always sort in descending order, for example, and you added like the biggest shard or the smallest shard to a node, and you have more cores than nodes, won't you have like too many big nodes, too many big cores assigned to the same node?
Okay, so the question is, like, could an operation lead to like the cluster being imbalanced after these operations? No, like, so how would I summarize it?
So basically, if you're like say sorting in descending order, so you took the smallest one, you assigned to the cores to a shard, and you have only two shards, so you're assigning cores to them. So you assign the first one, then you assign the second one to the next one, and say all of these are candidates based on policy, so you go with the policy one.
Sure.
Then you get the third one, and then you assign that again to the first one, and then the fourth one to the second one. So if you do in this way, you would get like 3 of the smallest on one, and then 3 of the biggest on the other.
Okay, so what you're saying is, will it always pick one till it stops exhausting those conditions, and thereby that node being the most heavily loaded in your cluster?
One node might be the most optimal, and the second one.
Right. So say if you set up a preference which said, you know what, or a policy which said anything with less than 1,000 cores is fine, but will that mean that my first 999 will end up going there or not? To summarize, if that would be a question. I'm not sure. AB, do you have a sense?
So the reason I asked is like we face this with like QPS. So we try to do like based on historical data, we computed the QPS that each core would have.
Okay.
We were trying to balance QPS, and then we try to do the same thing. Like we sorted in descending order,
But you'll
and
pick.
then assign.
Mhm.
And what happens is like some shards get like hotspotted because like even though they went by your preference,
Right.
the way just because you assign by descending
Mhm.
order, some shards will be more.
Hot, yeah, yeah. So at that point, did you just pick 5 and do math dot random?
What we tried a couple of things, and one that gave us best results is bin packing. So we applied bin packing algorithms, like we sorted them. So first we assign like each shard the largest ones by the criteria, and then we reverse sorted, and then assign the smallest. So the guy that got the largest got the smallest the next time. Again, like it was
Sure.
it's a very approximate way of
Right.
doing, but I was interested if you guys
Yeah.
are doing
So,
better decision than
yeah, I'll have to check that offline, but to summarize, the question was, if I have a very like crazy rule criteria which said anything less than a million QPS is fine, right? Will it always start preferring one node versus the rest, given that I still have a big cluster? So yeah, let's check it out offline.
I have one question. You said that suggestions won't be made unless there's a remedy.
Right.
So do I get a notification of some sort that there is a violation? That's information I want to know.
Right. So, and that's the thing that we're still like, today you can get that, but you get that through the diagnostics API. So there's a diagnostics endpoint which will say, here are the sorted nodes and here are the violations. And then there's this suggestion endpoint which is giving you only when it's a violation and when there's an action possible. So there's this two sort of an bifurcation there today. Cool then. I hope this was informative. Thank you.